output are totally different.
Okay. So yes, now.
And figure out why it's the comparative thing. That's when the variables not being used. So when you use it, it puts the actual.
So we want to do that modulo arithmetic. It's technically not modulo arithmetic, but we're going to use modulos. Where does the modulo part come into play in this problem or in this code?
R.
With R simply wants R percent of K. Right? When you want 10% of 100, you're not doing 10 modulo 100. Like 10% of 8, you're not doing a modulo. Okay. Any other thoughts? Alright, before we get to that part, the mathematical aspect of things, we want to do our usual stuff, so include IO stream. I'm going to go ahead and use std. Let's see. So I want to enter the first number. Now, there is a characteristic about the first number for this activity, which is the first number must be 12 digits long. Yes, I kind of put that hint in there, said long, right? So if you simply define int, I'll do first num and cin. Now, when we went over cout and cin, I mentioned that oftentimes when we first learn C++, you would confuse the direction of these arrows. Some people think in a strange way. Now, how do I know? Because I think that way. So to me, the way we have here is not intuitive, right? For me, cout would mean the arrow or the sign should point in the other direction. But to avoid that thought process, you can look at it this way. You have that string that is taken and put it out in the console, so to the left. So that goes out in that direction towards the out. And whatever that's in console, it's coming into first num. So just draw an arrow, which would make better sense. I believe the book does it too. But I used to confuse it a lot when I first learned C++, so I completely understand what's that. Oh, forgot the most important part. So I forgot main. So we need int main first. So one of many things why people find C++ difficult, because it's picky, and there are loads of things that you've got to pay attention to in terms of syntax. So that's all I have. Hopefully it runs this time. Okay, so I want to enter a 12-digit number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 0, 0, 0, boom. Oh, have one extra digit. But regardless, it's not going to run. Yes? What is the issue? This is what we call overflow. So a specific variable, we all know, gets stored in random access memory. When you define int, a certain amount of memory is allocated for that particular variable. And if you start putting a huge number, you're going to cause overflow in the memory. Sometimes, if an overflow happens, it will show in the output. Perhaps if you enable debug, it might show. So how do we fix this problem? Well, there are different integer types which will help us get a huge integer. One, long int, another, long int. Yes? Each of them have a range, and I'm not sure if Jordan, did you say long int doesn't work? So, even I don't know the ranges by memory so you can Google. Each data type has a numerical range, so you can only use numbers within that range for a specific declaration. So in this case, it has to be long int. The next one, for the second number, I'm going to use simply integer. I need another variable for input, and that value is r. So what should that input be? It could be double, it could be integer. Let's not limit ourselves. I'll put double. So that is for the input. Now, I have given you a very specific number, and that number is 1984. 1984 will remain unchanged throughout the code, so what should you use? You use a constant data type. So I'm going to do constant, I'll call it val. Again, uppercase, I'm using uppercase because typically that's programming style. Constant data type is denoted, or people often use uppercase letters. I'll just call it val and put 1984. That will not change. It'll stay as val. So I got the first number. Now going to get the second number. Mind you, I am not doing any sort of checks. I'm simply getting inputs. Later on, when we get into logic and loops and things like that, we will put conditions. We are heading in that direction. So, going to get the second number. Now I want to divide the first integer by the second and multiply the remainder by 1984. Yes? Thank you. It's constant int. Where was I? Divide the first integer by the second and multiply the remainder by 1984. I saved 1984 to val. I want another variable for the remainder, so I'll just call it my underscore remain. Again, don't Of course, it is your programming style. You do what you want, but I will not recommend you defining variables as you go along. All variable declarations and initializations should be in the top, or it is better if they are in the top. So that's why I keep going back to the top. Easier to debug. So I've got the first number, I've got the second number. Now I have to divide the first integer by the second. So should I do division? Or should I do modulo? Why? Done. Because I want the remainder. Sure, we could find it, using different approaches, but we have modulo. So let's just take the first number, and we went over modulo last time. So percent, second number. That is going to give us the remainder. Once we have the remainder, we want to multiply it by 1984 and save that variable to k. Now the remainder is it going to be an integer, or is it going to be a flip or a double? It's an integer. It's a remainder. Have you ever seen a decimal remainder? Algebra people. It's not possible. So it's an integer. So I am going to define k to be an integer. Should we do int, long int, or long int? To be on the safe side, it is best to call it long int. Now, you're not doing anything wrong, you're just allocating more memory. That's perfectly fine. So I'm going to call it long int to be on the safe side, because I don't know what sort of number I'm going to enter. So k would equal to my underscore remain times 1984 is my fixed constant, so that. Yes? Could you have typed in 1984? Yes, but the purpose of the exercise is to demonstrate, well, if you have an activity where you have a fixed value, it's better to use the constant data type. This way, once you fix it, it remains as is. Okay, so we have the value k. We want the value r, so std cout going to enter the value r. This is going to be a decimal number. The reason being I called it a double. Would it be an issue if you have it as an integer? No, it'll convert it to double. So std cin of very last step. Asked you to find r% of k and print. As I went around, r% of k, everyone or people who got most of the code right typed it as r percent k, right? That is incorrect. Why?
Because that's modulo.
That's the modulus, or that's the modulo when you put percent. So how do you get percentage? Well, there's only one way, and that is go ahead, Zander.
Divide by 100 and multiply.
Going back to algebra, the final answer is take R, divide by 100.
Plus, you wanted the percentage, so you wanted the modulo.
Come again?
I thought you wanted the modulo as much a percentage.
Oh, said R percent of K. I mentioned it in words, right? R percent of K. I didn't say R modulo.
The operator for modulo.
Ah. So that's okay. So if you want to find percent, don't put percent sign. Percent stands for modulo. So R divided by 100 multiplied by K. Hopefully everything works. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 2, 2. 12 digits. Second number. Give me a 3-digit number. 1, 2, 3. 816. The percent, I'm going to go for 2.08. It's a double, so it can take 2.08. Could I put it as 2.08129? Zander says yes. Why is that, Zander?
It's stored in a double.
Because it is stored in a double format, double position, so you could have more decimal digits. So enter. So the final answer is 27,979.2. Yes? Few things to know. First bit today is to understand overflow of a variable. Use long to prevent overflow. We're using a constant because it's a fixed value 1984, and to find the remainder you use modulus. And modulo is done using percent in C++. And to find our percent of K, you have to do basic math over 100 times K. Yes? Are we clear?